Hey folks, Thomas here. Welcome back to Mears Lab. In today's video, we're going to take an in-depth look at how much it costs to build your very own tube amplifier from scratch. For today's video, we're going to feature the Fender Champ Model 5F1 because it's a really beautiful and basic circuit and it's a really great one to get started with. A lot of the information that we're going to cover in this video will also apply to many other amplifiers from pretty much any other manufacturer as well too, because the components that are used between different brands and models of amplifier are very similar in many ways, and you'll see that throughout this video. We'll go through the schematic part by part, and we'll also cover the hardware that's not featured on this schematic as well too, so that you can get an idea of what the entire build is going to cost, including all the resistors and capacitors, the tubes, transformers, the chassis, and that sort of stuff. Let's get started by discussing where I get my parts from. And just before we get into that, I want to mention that I'm not affiliated with any of these companies whatsoever. I don't get any discounts or anything like that from them. This is just where I prefer to get my parts because I find it's the best value around. So for a lot of the actual parts like the chassis, the hardware, stuff like that, like the pilot lamp, transformers sometimes, I'll get them from this place here called Next Gen Guitars. And I'm in Canada, and this is a Canadian retailer, and I find they're really great service, great shipping costs, great shipping times, great stock, and I really like the components and parts that they have. They have a lot of really nice brand name stuff, and I've had great experiences from them, so I can't recommend this company enough. They're awesome. Okay, and for parts like resistors, caps, and like most of the components that go inside of the amplifier, I like to get as much stuff from DigiKey as I can because I love the cost of the shipping. It's only like $8 if you have to pay shipping, and over $100 it's free, and stuff shows up really fast all the time, and they just have such a huge selection of parts. The website's a little tricky to navigate through, but on that note, I have another video that, for example, describes how to pick caps on this website and hopefully helps sort of make that a little bit easier to understand how things are laid out in the website. But anyways, once you get past that, it's a really wonderful resource, and DigiKey is great. Sometimes I can't get the parts I need, like generally it's usually just transformers, and I will go to Mouser for that because I think that Mouser has a bit of a better selection of transformers than DigiKey does. I generally go with Hammond branded transformers in all of my stuff. There's lots of other great brands out there, but I like to stay Canadian, and I really like Hammond transformers. So that's why I go with them. And Mouser has lots and lots of them available, and DigiKey has some as well too. And I find the pricing is very comparable between these two resources. Oddly enough, actually, if you can get transformers from Next Gen Guitars, they're a better price from here for the most part than they are from these other places, which I find is interesting. However, you know, if you're buying in bulk, you could probably get a much better price from these places because that's sort of what they're there for. But I have a feeling that maybe they would hook you up if you were looking to buy like 10 transformers as well too, so who knows. But yeah, that's what I wanted to mention about where to get the parts from. Okay, so I guess there's no better place to get started than by looking at this schematic here. Let's get into it, folks. Okay, so let's start with something like the resistors, okay? Because you can get all of the resistors from the same place. Now, Next Gen Guitars does sell the resistors, but I think that it's better to get them from DigiKey. So this is how I would look for those. I would look under the passive components right here, and you can see there's resistors, so we'll click on that. And we're looking for through-hole resistors, which are like the type that are used in guitar amplifiers. And first thing I'll do here is I'll check off all the products that are in stock because it cuts out a lot of the results, brings it down from 500,000 to 24,000. So we'll do that and apply that. And then I think the first thing, or the next thing I would do is probably pick the power rating of the resistors. And let's just choose 1 watt right here. The reason I chose that value is because you'll notice on schematics, I'm not sure if they mention it on this one or not. Yeah, you can see here values are plus or minus 20% here. So as long as your tolerances for your parts are within or plus or minus 20%, you're okay according to this schematic. Sometimes that tolerance is a lot lower, and the lower, like the better tolerances you use throughout all of the parts when you're selecting them for your builds, the more, the closer the end product will be to what the design was. So that's something to keep in mind. But you know, that's not a hard and fast rule. You can like widen the tolerances as much as you want. You know, that's part of the fun of building and designing yourself. You can choose to say maybe make some of your resistors really high tolerance, but other ones leave them really wild, and because maybe that does interesting results to your amplifier. There's lots of open-minded ways to look at it. Yeah, so anyhow, sometimes on the schematic they'll also say, like, if it's not indicated, all the resistors have to be half a watt or more, and that's something I see in a lot of schematics. Is half a watt tends to be like the sort of the gold standard, and so I like to go to like a 1 watt, because I find the price difference isn't really all that big between like a half watt and a 1 watt resistor. So why not just like go up another step and pretty much never have to worry about them overheating, right? You know, look, of course you're gonna have to worry about it a little bit, but yeah, you know, there we go. So we've got the wattage applied and the in stock, and look at that. Now we're down to only 2,471 results. That's great. Okay, but so next, well, let's just pick like a value like I don't know, 10K. Let's go with that. Oh no, let's go. Yeah, no, 100K, because that's like for the plate resistors, and it's very common. Okay, so look at that. As soon as we select that, now we've only got 39 to pick from. So it's a heck of a lot easier with just a few little options here. And now we can pretty much, because we know that everyone that's on this list is going to be the right power and the right resistance. I think that the only other things to really consider would be price, would be a really big one. But another thing I like to consider is the composition. This is like the actual type of resistor. And real quickly, like carbon film resistors, that would be like the vintage sort of style ones. And they're great. They look really cool. But quite frankly, technically speaking, they're not the best choice anymore. There are better options, and the better ones are metal film resistors. I'm not going to go into the nitty gritty about how they're made and all that sort of stuff. You can look it up on Wikipedia. It's a really interesting read. But yeah, metal film are better than carbon resistors. They're like a more modern design. They don't arguably look as cool, no, but you know, that's, you know, they look cool in their own way. And a better version of metal film resistors are metal oxide film. These are, I'm pretty sure, pretty much like the best ones you can get. And so I would, you know, you can go right up here and you can just select metal oxide film. So let's just look at those. Now there's only 9 options that come up for a 100K resistor. So this is probably going to show basically different brands now, and some slight variances in the brands. And I think one of the only other columns I might really consider at this point would be operating temperature, because theoretically a better resistor would be like this one can operate at these intended values between minus 55 Celsius and up to 235 degrees Celsius. The higher temperature rating is probably a more important one to look out for, because that's generally what we're looking out for in an amp, is when it's overheating. You know, it's usually not in these frigid temperatures here. Like most folks aren't playing outside in a snowstorm, you know, but you might be playing outside in a hot day with the sun on your amp. And that's why this upper temperature is a big difference. Like, look at this one. It's only rated up to 130. This is like 235. And the difference between these is 30. Well, this one is 33 cents and that one's 25 cents. So like, why wouldn't you go with this one? Sure, it's this brand, Yageo, which is, you know, who knows what. But on that note, I have bought and used and installed tons of these resistors, and they are awesome. This is a great brand, so no worries about that. And, you know, TE connectivity, maybe they're like, I don't know, but according to the price, maybe it's not as good of a resistor, but you know, according to the stats, no, it's definitely not as good, because this one can way outperform it in terms of higher temperature. So I'd probably go with that Yageo before I went with this TE connectivity over here. Yeah, so you could further, you know, like narrow this down by just selecting the temperatures that you want, but you know, there's only 9 results right here, so I'll just leave it like it is. And here's what I'll do next is I'll sort by price, so that I can just see, okay, so the most affordable one would be 25 cents, and then I go right up to the upper end and I see, oh, look at this Vishay one, which is a great brand name, is 63 cents. So, you know, all things considered, like on this schematic, I don't know exactly how many resistors are here. I guess we could count them up, but there's something like a dozen resistors on it. So like, let's go back here. So let's, like, if there's like a dozen resistors and the difference in price is like 50 cents each, then it's only going to be an extra, what, $6 to like install the best ones? So why not go with the best ones, sort of a thing. These are areas that you can make vast improvements in your designs, and this is where you can really make a difference in the long run. So don't cheap out on resistors, because really, really good ones are also pretty cheap. So yeah, here you go. Now the different values are gonna, like if you pick like a 1 meg resistor versus 100 ohms or like 50k or whatever, yeah, the prices are gonna vary and all that sort of stuff. But generally, you know, it's worth it to go for the nicer quality ones, and by nicer quality, pay attention to the temperature ratings, and you know, it's kind of fun to have a brand as well too. Like lately, I'm really digging these stack pole resistors. I just bought a whole ton of these ones, and this is sort of what I'm putting in my design, because the price is sort of right in the middle, and I don't consider myself like a top of the line designer or whatever, you know. And I also don't consider myself like a total beginner either. So I sort of see myself in the midpoint of my amp building journey, you know. So I think that's another reason for me to go with these ones. And they got a great temperature rating as well too. So yeah, there you go. That's why I go with these resistors. And you can generally use the information we just spoke about in choosing resistors for pretty much all the different values of resistors in tube amps and lots of other builds as well too. So let's move on from there and discuss capacitors. Now, there's not too many in the Champ 5F1 circuit, but there are a few capacitors, and they're the the filter capacitors here in the B plus section, and they actually don't have any cathode bypass capacitors in the preamp tube, but they do have one in the 6v6 power tube right here, this 25 microfarad 25 volt one here. So let's have a peek at where we could get capacitors. All right, so I've got to mention that if you wanted to get sort of like the gold standard, if you will, of capacitors these days, a lot of folks really, really like these. Let's look for them on Next Gen Guitars, because this is where you get them. I can't find them from these other suppliers, but you can get them from Next Gen Guitars. And they're this brand here, these F&T caps. They're really expensive, but they are really, really nice. And the cool thing about these is they're basically one of the only manufacturers making super high quality axial capacitors like this, where the leads are coming out either side and not both coming out one side, like then they were called radial ones. So that's why they're a bit more expensive. But do keep in mind, if you look at the data sheets for these do not perform as well as radial capacitors, and radial capacitors are also way more affordable as well too. So keep that in mind. I'm not going to go down the rabbit hole of all of the capacitor voltage ratings and life ratings and temperature ratings and all that sort of stuff, but it is a really fascinating read, so I recommend you look into that on your own sometime. Yeah, so if you wanted to get F&T caps, go to this place right here, Next Gen Guitars, and you can get all the values you need, the 22 microfarad 500 volt ones for the filter section, or like 10 microfarad, and you can get those cathode bypass caps here, the 25 microfarad ones from here as well too. Yeah, there's a few different pages, so you just cruise around here and you'll find what you're looking for. If you'd like to go with a different brand of capacitors, say like Rubicon, which is generally what I go with these days, or Nichicon is really nice too. Let's see here. Yeah, you go to passive components and then capacitors, and then aluminum electrolytic capacitors. Same deal as before. We're gonna narrow it down with the in-stock products, and let's just choose, say, like 22 microfarad, which is a pretty standard value, and we'll pick that, and we'll just hit apply all. And then for the voltage rating, we could say pick like 450, or we can pick multiples of these, pick 450 and 500, or we could just go like this and we could say 25 all the way up to there or whatever. Oh, whoops, it didn't really work, right? But yeah, I think you know what I mean. Anyhow, let's just look at the 450 volt 22 microfarad caps right now. See, there's only 63 that pop up, And here's another one I really like to pop in right here. I like to go with the longer lifespan capacitors, so I'll just choose all of the ones that are 8,000 hours or more and eliminate all the low life ones. Because I think that the price difference is worth it to go with a higher quality capacitor like that. So here we go. Here's the brands that pop up, and I'm just going to choose Rubicon, for example. And you can just choose whatever brand you prefer, but once again, I really like the Rubicon caps. We'll sort by price here, and we can know with confidence that every one of these capacitors on this list is going to be dynamite. They're all going to be awesome because they all have high lifetime. They are all the exact value that we want, and they're from a great brand name, and they're all really great prices as well too. You can see the most affordable ones, $2.64 Canadian, and it goes up to $3.87 Canadian here. So something else maybe to consider is the size of the capacitor, because some of them are shorter and some of them are taller and wider and stuff like that. And sometimes that makes a difference with the chassis. For example, like a lot of chassis are have like a 2-inch depth, and some of these caps, like most capacitors, are generally like an inch sort of tall, not including the leads, or maybe about like 5/8 of an inch tall. And so if you've only got a 2-inch depth chassis, that means you only have another inch to work with to squeeze like the turret board in there, and then like the standoffs for it and stuff. So you want to consider that. I generally go with shorter capacitors because there's a bit more room to stick them inside the chassis. Yeah, and that's how you can find the capacitors for your build. Oh my goodness, folks, you know what? I think I almost forgot one of the most important parts of the tube amp, and that is the tubes themselves. Okay, so here's where I recommend to go for the tubes. I go to a place called the Tube Store. Let's see here, let's bring it up. Here we go. And I really like the way the website is laid out, and the prices are great, and the selection is fantastic up here. I just absolutely love this store. I've gone here quite a few times before. Let's look at, say, like preamp tubes, like 12AX7s, and there's just so many nice ones to choose from here. Look at that. You can see like these awesome GE, like vintage ones. They're expensive, but they're really nice, you know? And look at that. There's some Tungsol right there, Electro Harmonics. Like all the brands are up here. JJ, everybody you could possibly want. Here's the ones that I really, really like are these Mullard ones. These are modern reproductions of the old Mullard ones. And yeah, sure, they might not come along with all the super duper cool factor of the old vintage ones, but I really like these. I think they're really cool, you know, and this is what I would like to put in all of my designs right here. So yeah, that's the sort of preamp tubes right there. But then once again, don't worry about it. Like there's so many to choose from. You could like pick whatever brand you want pretty much. And they're all around this same price. This is a US supplier, so you'll probably have to pay a little bit of customs if you're getting them across the border to Canada. But even so, I really like this company so much. I really like getting their stuff from there. All right, let's take a look at the power tubes. We'll just go up here and click on 6V6 tubes. You can see that right here on the schematic, the 6V6, it uses one of those for this Fender Champ F5F1. And here they all are. There's this beautiful Mullard 6V6 GT that would be perfect for a build. It's a really nice tube. You know, you don't have to go with one of those. One of these JJs would be just fine and dandy, and these Tungsols are really nice as well too. So are the Electro Harmonics. They're all great tubes, but they're all slightly different as well too. So this is where you're going to be able to find those, and this is about how much they cost. Okay, you know what? I think we need to go back here to capacitors again, because we need to have a look at where to find these coupling capacitors right here. We didn't take a peek at those. And here's how you find those. Let's go back to the DigiKey here. We'll go to the capacitor section. And let's pick these film capacitors. These are the nice ones to use for coupling caps. Once again, we'll do the in-stock thing here and apply all. We need to pick the voltage rating, the DC voltage rating. And what I like to go with is everything over 600 volts. I want to see everything over 600 volts. Okay, holy cow. Yeah, we probably don't need to go up that high, but sure, why not? Let's go for it. Okay, and oh, here's a big one that you got to remember to do here for this one is pick through holes, so we don't see all these chassis surface mount parts, because we don't want to put those in our tube amp. Okay, here we go. And so now we've got all of our proper voltage rating, our through-hole ones picked here. And let's just pick a value here. Let's pick like, I don't know, like this 1.1 microfarad. And we'll go with that. Actually, sorry, no, let's not go with that rating, because that's not what's in the schematic. The schematic uses these 0.02s. So let's go with that. And that would be right here, 0.022. And we'll hit apply all. And look at that. Now we got lots to choose from. I tend to go with Panasonic brand ones because I really like them. I think that they're really nice, and I've been using them for many years now, and they work great. So I'm just going to pick those, and let's sort by price. And let's get into the nitty-gritty details here a little bit. And what I mean by that is the dielectric material. Okay, because there's two different types that come up here. There's these polyester ones and these polypropylene ones. And the difference is the polypropylene ones are better. The polyester are kind of like the more affordable ones, but polypropylene ones are like a better quality build. It's sort of like the back with the resistors, how there's carbon ones, metal film, and metal oxide film, and the metal oxide film are the best. The polypropylene ones would be the best and are generally the more expensive ones as well too. You see, I sorted them by price, and the more affordable ones are these polyester, and then the polypropylene ones actually get pretty darn pricey when you look at them. The better quality ones. But we don't necessarily have to get those better quality ones. These are all decent, and they all are going to operate within the DC blocking voltage range that we need. So we don't have to worry about that. And the AC voltage is never, ever going to be anywhere close to this, so we don't have to worry about that. Okay, so, I mean, I guess it is something worth considering, of course, you know. But, like, look at these AC voltage ratings, like 200, 700 volts. Like, it's never going to be anywhere close to that. Okay, so, like, this Panasonic one right here would honestly be a really great choice. It's got a 10% tolerance, and look at the leads are really long on it. So although this is not an axial capacitor, this is a radial cap, but like it's really easy to bend the leads, and they're really long, and they work just fine for like spanning the gap on most turret boards. So yeah, these would work great. The only ones I wouldn't really recommend would be like these ones right here with these short leads, because they're kind of difficult to mount on turret boards and stuff like that. Yeah, so maybe something like, let's look at the most affordable polypropylene, which is this one right here. It has short leads on it. So let's look at this one, short leads, short leads. What's this one? Look at that one. That's beautiful right there. Okay, so $1.21 each. Eugh, that's getting up there. I don't really like paying those sorts of prices, but you know, got to do what you got to do. And look at that. Now that is an absolutely incredible capacitor. Look at these temperature ratings, minus 40 to 105. That's what we want to see. Look, the best ones, that's what their temperature ratings are. And we've got plenty of voltage to spare here. You know, sorry, yeah, right here. Look at this one. Look at that. DC blocking voltage, 1600 volts. Like it's basically never going to fail. 700 volts for AC voltage. Its tolerance, 5%. This is a spectacular capacitor. And look at that, $1.21. And there are two of them in this circuit. So there you go. I think that we can spring for the extra buck or whatever that it's going to cost, or $2 that it's going to cost to put these in here, and know that it's basically an indestructible capacitor that will almost never fail. So yeah, that's where you're going to find the coupling capacitors. Now let's take a look at the potentiometer right here, and for that matter, pretty much all potentiometers. I like to get them from Next Gen Guitars because they have a great selection, and the prices are really good on their potentiometers. I don't know how they're able to sell them for these prices, but they sure are nice. Okay, so here's how it breaks down. This brand Alpha makes great quality pots, and the feel is quite nice on them as well too. You know, they're not too stiff, and they're not too loose either. And the price is wicked, $3 Canadian each. Can't beat that. I really like these, and I use these for a lot of my builds. The better quality ones are this brand right here, CTS. And look at these beautiful like gold shafts. And these have this sweet J taper on them, which is like a non-linear taper, and it's like even more closer to what the human ear hears than the other taper, which is like the A taper on a pot, and B would be like the linear taper ones. And so generally this would say like this one right here, like this solid shaft 1 meg J taper pot. This would be like an absolutely spectacular volume pot right here that would last a really long time and sound super good and feel super good. And look at those leads. They're like, oh sorry, those lugs. They're so beautiful, so nice and easy to solder to. Oh, so great. Can't recommend these enough. Those are the kind of pots I'd recommend you go with. But if you want to save a few bucks, you can go with the Alpha brand ones, and they're really nice too. These Bourns ones are great as well too, but I find they don't have as wide of a selection of those. They have a great selection of CTS and Alpha, and that's what I'd recommend you put in your own builds for potentiometers, and I recommend you get them from this place right here, Next Gen Guitars. Next up on the list is one of my personal favorite things, or it's the transformers. I am obsessed with transformers. I can't get enough of them. I love reading about them and everything there is to know about them. They're so fascinating. And I really believe that they contribute a lot to the sound of the amplifier. Maybe not so much the power transformer, but absolutely the output transformer has a lot to do with the character and tone and feel of an amplifier. So without further ado, let's have a peek at those. And it's really, this is a wonderful resource for finding transformers right here, Next Gen Guitars. And we'll get down the rabbit hole a little bit on them as well too, because I just can't help myself. They're so much fun. So let's click on transformers here, and let's find a power transformer, okay? And we'll get into how you select the output transformer here in a second. And trust me, it's a lot of fun. Here's how we're gonna pick a transformer. It gets pretty technical and complicated, but I'm gonna do my best to keep it as simple as possible, okay? And once again, it is pretty fun. So there's a lot to choose from here. Look at all these different pages. So let's just sort from let's sort with this price ascending here. And so this can show us the most affordable transformers all the way up to the most expensive ones. So they start around $70 and they end up around like $200 each for a power transformer. And I find that output transformers are sort of like that as well too. So, you know, you're generally going to be spending about $100 to $200 on each transformer, depending on, you know, the quality of it, sort of a thing, and the power handling and stuff. However, with a single 6V6 tube like that is in this, so this is a single-ended amplifier running in Class A, it can only really produce so much power, so there's no point in really putting like a super powerful output transformer in it. But, you know, we'll discuss that in a moment. Let's stick to the power transformer here for right now. Okay, so I think the first thing that we need to make sure is that it has the correct sort of wiring, the transformer. So in this amplifier, what we need is so here's the power transformer right here. So it needs to have this primary side, and yeah, all transformers are going to have that, so no worries there. And it needs to have these secondary filaments here as well, or secondary wires as well too. Okay, so here's the high voltage one right here. So this is the one that's going to be like 300, 400 volts, that sort of a thing, okay? And if we look over here, if we were to say click on this, say like this Hammond 290WX, we'll see that it has 237 volts RMS, and it can supply that at up to 50 milliamps of current. Okay, so that's a really, really important thing to pay attention to right there. This voltage and especially the current that it has. You can see that its secondary is the primary, and then the secondary also has this filament winding right here, which is 6.6 volts, which will be fine at 6.3 once you put a load on it, you know, with the filaments at 1 amp. Okay, but it's not a center tapped filament, so you would have to create your own center tap with a couple of 100 ohm resistors if you were to use that one. But yeah, you can see on here is the 6.3 volt filament. But you'll see on this schematic, they don't actually use a center tapped filament, so it's going to be a bit more noisy. But that's a little mod you can do is if you were to say, for example, pick this transformer to build this amplifier, which technically you could actually use this transformer for the build. Yeah, you would simply take a couple of 100 ohm resistors and you'd wire those from either side of this to the ground, and then that way you get like a center tapped situation, and it keeps the noise down in the amp a bit and makes a big difference, I find. Anyhow, I don't want to get too far down that rabbit hole right now. We're discussing the parts and how much they cost and stuff, so let's get back to that. All right, so this is the this one up here, this was the 5-volt filament winding right here. So if we wanted to go with a tube rectified version of this 5F1, which is what this schematic is right here, then no, we couldn't use this transformer because it has no 5-volt filament winding. Okay, so we would have to make a solid state rectifier out of diodes instead, which we could do that, but let's not do that right now in this video because that's a bit more complicated than we want to get into. We want to just stick to this schematic right here. So no, that transformer is not going to work. So let's go back here and let's find one with a 5-volt filament that would work. Now there's a faster and easier way to find it, and here's how you do it. Let's go to Hammond's website. So we'll go to Hammond Transformers. We'll just type that in here. There we go. And if we go to audio transformers, or sorry, power transformers, sorry. And we just scroll down this list right here. And we can go to, here we go, classic high voltage tube plate right here. So let's look at the 200 series, because this is sort of like the kind of power transformers that we're going to use for this sort of a build. And look, here they are all listed, all the ones that they make, and they're organized by voltage and filaments. So this is great. We can quickly and easily pick the one that we know is going to work. Okay, so in this amplifier, it uses a 5Y3 rectifier. So this has a 5-volt filament, and it needs 2 amps of current, okay? So we can figure that out by, say, looking at 5Y3 data sheet. Google that, click on this thing right here, and zoom right in here, and we can see yada yada yada, boop-a-doop-doo. Where is it written on here? Yeah, there you go, current, 2 amps, okay, 5-volt filament. So that means we need to find a transformer that can supply 5 volts at 2 amps. And you don't really got to worry about that because that's kind of like the baseline of all these. So they're all going to supply at least that much current. So you don't got to worry about that so much. You just got to find one that has a 5-volt filament. And then the 6.3 volt filament, here's how we figure that out. Okay, so there's only one 12AX7 tube here. And if we look at the data sheet, okay, I realize I'm kind of talking kind of quick here, but we got to cover a lot of information really quick here. So just hang in there with me. Okay, so let's bring up the 12AX7 data sheet. If we look at that, we can see that under the electrical information here, that when you run the tube in series or parallel, it'll pull either 150 milliamps or 300 milliamps. So at the most, one tube is going to pull 300 milliamps. So we can rest assured that basically all of these are going to work just fine because it only needs 300 milliamps for that 12AX7, but we also have a 6V6 that also needs some current from that 6-volt winding as well too. So let's look at the 6V6 data sheet to see how much current this tube needs. So let's click on it right here, zoom in a little bit, and you'll see that, where's the electrical information here? 2 watts, 12 amps. Oh, right there. There we go. So 450 milliamps. Okay, so there we go. 300 plus 450, that's 750 milliamps. So as long as we find a power transformer that has a 5-volt filament at 2 amps and a 6.3 volt filament at least 1 amp, only 1 amp is all this amplifier would need, then we'll be just fine. Because those needs are actually so minuscule in the terms of tube amplifier builds, pretty much any of these are going to work. So then the next thing we need to look at is the operating voltage, which is very important to get this correct. So on this amplifier, it doesn't say it on here, but it does mention it over here, I think, what the plate voltages are supposed to be and stuff like that. Where does it say it on here? You can probably see it already. Yeah, right over. Yeah, so 3, that is the plate right over here for the 6V6. Look at that. Looks like 340 volts. So we want to find something that's like 340 volts-ish. Let's look at these this 5Y3. So let's look at how this actually works. Okay, so if we were to look at this, say, typical operation with a capacitor input filter, AC plate voltage, 700 volts right here. If we were to supply it with 700 volts RMS, like, and then once again, say like one of these 700 volt transformers here, go back to the 5Y3, then that means that that rectifier tube at full load current of 125 milliamps, it would output 350 volts, which is sweet because that would be way more than enough to run this amplifier. Something else to consider for, say, while we're on that topic of the current that this 5Y3 can supply, is we got to look at this 6V6 and how much plate current it's going to need. So say if we were to run this in a single tube class A, which is exactly how this 5F1 is running, then let's zoom in here a little bit further. And we looked at, say, this supply voltage of like a plate voltage 315, and we're going to run it with, and so this fender amp actually runs it a bit higher than that. So that means that the current is going to be a little different, but this at least gets us into the zone of approximately what it's going to be, you know? So yeah, at about 300 volts plate, there we go. We can see all these different characteristics. Like we're going to, you know, probably need this sort of load resistance for the output transformer, and it's going to produce this much, you know, wattage at this percentage of distortion, and that sort of thing. But here's the number we're looking for right now, is this 35 milliamps at the maximum signal plate current, and the zero signal is 34. So as long as the 5Y3 can supply that, and it can, it has way more than enough, it'll do 350 volts, 125 milliamps, then we know that we're good as gold. So here's how we're going to get to that. We want to find a 700 volt transformer, and that can supply that sort of current. Okay, so here we go. Let's find bada boom, bada bing. Look at this one right here. Say like this 273BX. That would probably work. Wow, actually that's overkill even. But yeah, so it's got that 700 volts that we would need for the 5Y3 at 200 milliamps of current. So way more than enough. You could actually use that same power transformer for a much bigger amplifier. But the price of this one, I bet, is going to be pretty competitive. So, you know, that would be a nice one to go with. 5 volts at 3 amps, which is great. You could actually use a 5U3 rectifier with this one because it has enough current to run that higher power rectifier tube. And 5 amps of current for the 6.3 filament. So no worries there. Yeah, so that would be a wonderful choice right there. Let's click on it and have a peek at it. And that's what it would look like. You can see the dimensions for it, how big it is up here, and like the windings, and look at all that. It's beautiful. And it even has I think it has a center tapped 6.3 volts. So you wouldn't even need those 100 ohm resistors, and it would be really beautiful. This would be a really nice power transformer for that amplifier. And so, okay, now we've got the model number for it. Let's just look it up. And I'm not, okay, now I just want to mention, I'm not recommending, for example, you use this exact transformer. This is just an example. You know, I would recommend that you look through the list here and you pick your own choice for what you want to build. That's what I would recommend. But let's say you did go for this one. Let's pop that model number in here, 273BX, and see if it brings anything up here. It might not come up on here because they don't have the hugest selection, but they do. Okay, 273. No, I don't see it here. Darn. Let's look over at Mouser because I bet they'll have it. 273BX. Okay. Oh, look at it right there. It does come up. Okay. And look at that. Okay. Yeah, they've got it here, and they've got 34 in stock. So to me, that says that this is a pretty common transformer that a lot of their other customers go with, because you'll notice that not all the transformers they have that number of stock in. Sometimes they only have 1 or 2 of them in, and that would be considered more of like a rarity, something that doesn't go out the door all that often. It doesn't mean it's like any better or worse than other transformers. It just means that you know, you can look at this number and sort of ascertain, okay, well, lots of other people probably go with this one too. And there's the price of it right there. So $176 for that transformer right there. Okay, and you'll find that pretty much all the transformers are going to be in that price range, give or take maybe 20 or 30 bucks. Yeah, so that's a power transformer right there. Okay, so now let's look at the output transformer. I love output transformers. This is so much fun. Okay, so let's to pick that out, let's bring up the 6v6 data sheet and look at this typical operating conditions section again, okay? So we are going to look at this column right here because this is closest to what this amplifier is going to be running at. And once again, we know that because if we look at the schematic, it says that the plate voltage here is going to be about 340 volts. And the closest that we have on this data sheet to that is 315 volts. So look at that sneaky Leo Fender running his amps at higher voltages than the tube manufacturers recommended. But there you go, that's innovation for you. Okay, so the important characteristic to look out for is this one right here, the plate load resistance, 8,500 ohms, okay? That's really important because that is going to have a lot to do with getting the right tone and especially the most efficient transfer of power through the transformer so that you'll get the least amount of distortion and the best frequency response and the most power as well too. So it's really important to get that as close as you possibly can to the design value of the tube that you're putting in it as well. Other things I like to pay attention to are the harmonic distortion values, although keep in mind that with a single-ended amplifier, it's always going to be high. It's just, as far as I know, it's pretty much impossible to get this value any lower than 5 or 6%, something like that, according to the data sheets, at least anyways. But who knows, I would love to learn that I'm wrong about that. So if I am, please let me know. Okay. Power output's an interesting thing here too. So there you go. At this voltage and these sorts of ratings right here, especially this load resistance, you could expect about 5.5 watts. What that means is if you were pumping a sine wave through this amplifier at, for example, maybe 1 kilohertz, that you could expect it to have about 12% distortion compared to the inputs, comparing the output shape of the waveform to the input. And it would be able to produce that at about 5.5 watts, which honestly would sound excellent. It would sound so good. And my guess is that running it at a higher voltage, you're going to produce more harmonic distortion and probably not a lot more power output than that. This is pretty much it. We can look up the ratings here. So these are the maximum ratings. And you can see that Tunxall themselves, they say don't run this tube any higher than 315 volts. And yeah, look at Leo over here, 340 volts. He's like, I don't care. I think that's so cool. Okay, yeah, but you look at this. You can run the tube up to 12 watts, okay? So he knew that you could run it way higher than this, and so that's what he was doing. And because he knew that added distortion might actually be kind of useful and sound good, So that's pretty cool. All right. With that information, we can start looking at output transformers. So let's go over here to Next Gen Guitars. I think that this is a wonderful resource to get output transformers. I really like how it's organized on their website. They've got really great stock as well too. So let's look over here, output transformers, and let's go price ascending. And now we're going to look for, so we could further narrow this down like this. And you know what? Let's just do that right now. Go upgrade for Fender. You know what? No, let's go the long hard way. Okay, so let's look at the most affordable one right here. So this would actually work for the Champ build, but you'd probably burn it out if you ran it at full bore. So maybe not this one so much. You can tell it would work. See this SE? That means single-ended instead of a PP, which would be a push-pull amplifier. So we need to look for a single-ended output transformer for a Champ 5F1 build. Something like a Deluxe or a Princeton or Bassman, they would use push-pull transformers. But this Champ, this little single power tube amplifier is single-ended. So yeah, we need a single-ended output transformer. And look at this one. It's got an 8 ohm secondary. So that would be where the speaker connects. And the primary is 7.5K. And that's pretty darn close to that 8500 that we want. So that actually is not so bad. But look at that power, only 3.5 watts. Meh, not so great. And I like to consider the way that the transformer looks as well too. Some of them are have this metal shielding around them, and some of them are open windings like this. And that's something to consider as well. Okay, so let's look at this. There's another one right here, 3.5 watts. Ooh, look at this one, 7K, 3.0. Only this one's 4 ohm output though, so you have to consider that with the speaker you're choosing. But it's 5 watts, so that's not so bad. Let's have a look at this one right over here. Look at that, 10 watts. That's great. 8 ohms. That's what we want to see. Perfect. This would be excellent. Although 5.48K. So this is going to really skew the output characteristics in a way that I personally find it really hard to to try to get a picture in my mind, or like what is it going to do to it. I like to try and stick close to this, but that can also be used to your advantage. You know, sometimes it's kind of fun to like put something in that's different than the design values too. So I'm not going to necessarily advise against it, but I kind of want to advise towards getting something closer to the design specifications. Now let's not get confused here, because this one looks like it'd be perfect. 15 watts, 8500, 8 ohms, but it's PP. That's a push-pull one. So no, that's not gonna work so well for us, unfortunately. So let's keep trucking along here and see if we can find something else that's gonna work. Something like that might work. Okay, let's have a peek at that. So what's that? Okay, so look at that, single-ended, 5 watts. Look at this, 3 different secondaries. It has a 4 ohm, 8 ohm, and 16 ohm. That is excellent. And look at the primary, 5,000 or 8,000 right there. So look at this for upgrade for Blackface 5F1. Precisely right there. They themselves recommend this for the Fender Champ 5F1 circuit. That would be great. Now let's look closer at the transformer here. You can see the frequency response, 70 hertz to 15 kilohertz, 5 watts, 7,000 ohms. And wait a minute, it's funny, that picture actually looks a little bit different than the specs are saying here. But anyhow, the specs are awesome on this, and this would be a wonderful transformer. It's pretty close, but you know, you can't always get exactly what you want, so sometimes you got to settle on pretty close. And look at the price is about 75 bucks. That's not that bad for that. What's this 1760F look like? Okay, is this, oh, that's push-pull, so that's not going to work out for us. Once again, we need to stay with a single-ended push-pull. 1760C. What's this 1760E look like? Is this push-pull? Yeah, that's push-pull. That would be for a deluxe right there. Yeah, so I think you get sort of the idea that I was discussing in here, though. So, like, I think maybe this 1760C, is that the one we clicked on? Yeah, that was the single-ended one. Yeah, so I think that kind of this would probably be one of the better choices, I would say, right now, just having a quick look at it for a Fender Champ 5F1 build, if you wanted to go with a Hammond output transformer. And this really would be, this will be a spectacular transformer for the build. So yeah, that's sort of some of the information that I look at for picking the output transformer. Let's take a look at the speaker now. You may not be actually putting a speaker in your own build. Maybe you're just building like a head or a chassis, and you don't want to bother with the speaker, but it's worth looking into. And I'll just have a quick little look at it here, and we'll look at these Celestion speakers at Next Gen Guitars, and we'll look at, well, I mean, we could look at like an 8 or 10-inch speaker, but if you're going to build it yourself, why not go with a 12-inch speaker? Because a Champ circuit through a 12-inch speaker, whew, boy, does it ever sound great. It really does. Now, it's not a very high power circuit, so that means that you want to sort of consider that with your speaker choice, because there's no point in putting an 80-watt speaker into a 5-watt amplifier. Like, it just doesn't make any sense. I think it's a better idea to try to keep the wattage of the speaker as close to the amplifier as you possibly can. So probably like this Celestion Rocket 50 would be a really affordable choice that would be, you know, somewhat reasonable for it. But you know, this is a very basic ceramic speaker. Not saying anything against it, but this is about the baseline of where you'd want to sort of start. Now, and it basically all these speakers are very, very similar, with minor differences in terms of like how the cone is made and like different dimensions and things like that. But these are all ceramic speakers, and they're sort of all in the same category. And they're all in that sort of same-ish price point, around 200 to, I mean, sort of like the mid 100 to 200 to sometimes $250 or so. And say like something like, if you were going to go with like a mid-grade speaker, I would highly recommend this right here, a Celestion Greenback 25 watts. This would be such a great speaker for a Fender Champ 5F1. Absolutely spectacular. Boy, oh boy, would that sound great. 25 watts, so it's going to have great sensitivity to the power range of the amplifier, really nice mid-range detail, and just really great frequency response. And it's just going to feel real great. So that's the one I would recommend you go with. Sorry, not that 16 ohm. You go with this 8 ohm 25 watt one right here. I would say, yeah, right there. That's the one I'd recommend you go with. But hey, what if you wanted to go with like a super duper nice one? Well, here's what I'd recommend for that, and it's right here, the Celestion Ruby 35 watt 8 ohm. I recently installed this in a speaker cabinet that went out for a customer of mine, and I was absolutely blown away with how incredibly good this speaker sounds. So yeah, I would highly recommend this one right here if you wanted to put like the best one in it. So yeah, that's what I have to say about speakers. Okay, I just gotta say, picking the hardware for the amplifier that you're going to build has got to be one of the most fun parts about building amplifiers that there is. Because you can just pick anything that you want. You know, you don't have to go with what everybody else uses out there. This is a chance for you to sort of make your mark in the world and do your thing. And it's so cool. The possibilities are absolutely endless, you know? All the resources exist out there on YouTube and in books and things, you know, to learn whatever you need to learn. And if you just go into it with an open mind, it is so rewarding. It is so, so great. So without further ado, let's get started on the hardware. And let's start by looking at chassis and enclosures right here. So let's look at amp chassis. And what we're going to do is we're going to sort by price. And so here's like the kind of like the lids or whatever that you could use for the bottom of the chassis. So we'll just sort of scoot past those here. And here we go. Look, there's a nice Hammond aluminum chassis. This is 10 by 6 by 2. That might be a little small for a Champ, but you probably could squeeze it in there. And look, $26.99 is what that's going to cost. This is a really nice chassis right here. Can't go wrong with that. You got a steel chassis right here, so different material, a little bit more expensive, a little bit heavier duty than the aluminum chassis. And then you've got a black steel chassis right here, which is, you know, just a different color. I think that it might actually have sort of like it might have a coating or something on it. I don't know that for sure. I haven't gone with that style before. I have gone with quite a few of these aluminum chassis. Like, look at this one. I just recently picked one of these up, and for my current amp I'm building, which is a push-pull 6v6 amp, I'm going with this chassis right here, and it's excellent. I really like this chassis right here. It's heavy duty enough for the transformers that I'm using, which are some big heavy duty Hammond ones. And yeah, it's great. You know, $35, can't go wrong with that. And I really like this 3-inch depth is really great for amplifier chassis builds. The 2-inch depth is far more common, but I like the 3-inch depth. However, I really like the 3-inch depth. I find it's a lot easier to fit everything in there, and there's more room for the pots on the front of it as well too, so that you don't have to worry about the lugs like hitting the edges of the chassis and stuff like that. So I really like this one. This is kind of the one I'm going to recommend you go with right here, you know. And yeah, so there's the chassis right there, but there's lots of other ones to choose from, lots of different prices. Let's look at the input jacks now. Okay, so let's look at jacks and plugs. Okay, and we're going to look for 1/4-inch jacks. And okay, so there's different brands here. I'm going to recommend that you just go right to the Switchcraft ones because they're the best. Okay, so there's a basic 1/4-inch jack right here. This is the one you're going to use for the output right here. This is what's going to go to the speaker output. And then you're going to use this one with the tip shunt. This is the one that you're going to use for the input of the amplifier, because this is the way that you get this input sort of switching situation going on over here the right way. And I'm not going to go into the nitty-gritty about how and why you do this, but this is the one that you go with right here. So you pick up this one and you pick up that one, and there's your input and your output for the amplifier done. The reason why I really like Switchcraft jacks is because they are really strong, and especially the tolerances are very tight on them, meaning that when you put a plug inside of them, it fits really well and really snug, and it just is very affirming when you put a plug into one of these jacks in particular. Now let's look at these amplifier parts up here, because this is where we're going to find fuses and holders right here. So you can pick the fuses that you want for the amplifier, and probably a really quick and easy choice for this amp would be, say, like these 2 amp slow blow fuses. You know, you pick up a package of those and you're just fine and dandy. And let's go back to the fuses and holders here. And yeah, there's a couple of different cool fuse holders right here. I really like this one right here, this generic 3AG type right here. And here's the Fender style one right there. They all work just fine and dandy. Jewels, lamps, and bulbs. This is cool. You can pick your favorite color jewel lamp, and these are really nice quality. I really like these amber ones myself. They're metal, they feel great, they're really, really nice. And you can get the lamp. There we go. There's the different bulbs right here, package of 10 right there. There's different currents of these. So this one's going to be brighter than this one right here. This one's only 150 milliamps, and this one's 250 milliamps. That's something to consider whenever you're picking the power transformer as well too, because this is going to use some of that 6.3 volt filament, and I forgot to mention that earlier, but hopefully you got to this part of the video and hear this part as well too, because that's also important. All right, and here's the lamp holders right here. I really like this kind right here, the Fender style one. I find it's really easy to install these, and it's really easy to wire them up as well too, especially if you need to put in that the 200 ohm resistors for a center tapped filament. It's really easy to just add them on here and then just tap them off to ground on the chassis or something. Reverb tanks, although the Champ doesn't use a reverb, here's where your reverb tanks are. We won't get into that. Let's look at the terminal boards and strips and stuff, because these are really fun to look at. And let's just cruise through here until we can find what we're looking for. Here's some standoffs and things like that, so you can get the turret board raised off the chassis. That's where you find that sort of stuff. These are really handy, these little terminal strips. You can get them in different lengths, and these are really handy for doing like a point-to-point build. If you don't want to use a turret board, I like to use terminal strips, and once again, you can get them in a bunch of different lengths. Here is a turret board right there, or that's called a tag board right there. That would work real great for a build. Only $12 for that. Oh yeah, look at these. I really like these terminal strips. In particular, this one right here I really like. This one's a bit stronger, but it takes 2 screws to mount to. I love this because you've got the center post right in there for the ground, and you've got 4 other ones right there. This is great for you pick a few of these up and then you just stick these in various places around the chassis, and it's a really simple and easy way to get things mounted wherever you want them to be, and they're only $12 each. That's great. I've used those lots and lots of times. And here will be sort of like your more premium options. This would be like, look at this turret board right here. That's awesome. Let's have a close-up look at that. So this will be beautiful, you know. You can mount all your parts to this, and boy, oh boy, would it ever look nice and be super easy to work on. A bit more expensive, and you need to make sure that it's going to fit inside your chassis with the tube sockets and the transformers and all that sort of stuff, and things are in the optimal placement. But yeah, that's a really, really nice option there for how to mount all the components inside the amplifier. Now let's look at the tube accessories here, because this is where our tube sockets are going to be. And this is a quick and easy one right here. I recommend these Belton ones because they're super good quality. Man, the fit is really snug. They last a long time. I really like them. This octal right here for the 6v6, pick up one of those, or actually pick up 2 of these, because you need one for the power tube and one for the rectifier tube. Then you pick up one of these 12AX7s for the preamp tube. You can get a shielded socket or an unshielded one. This one allows you to see the tube a bit better, but this one allows you to put a cover over the top of the tube. And it's a little bit of a better mount as well too. It's just like a slight technical difference, but mostly a visual and aesthetic thing. But either of these are just a fine choice for the tube sockets for the preamp tube. Cable and wire, let's have a peek at that. I actually haven't bought wire from them before. I already have a big supply of it here. But generally, I like to use solid core wire in my builds. And I like to use cloth wire or silicone wire, because cloth wire doesn't melt, and silicone doesn't really melt all that much either. So it's worth it to spring for a little bit nicer quality wire in your builds. And you definitely want to make sure that the gauge of the wire isn't too tiny either, you know, but you also want to make sure that it's not too big either, because that's sort of also kind of annoying at the same time. So, you know, something like 20 gauge 18 gauge, 22, something around there is just fine for the wiring. And you can use stranded wires as well too. I just find it's a little more difficult to work with. However, it has its benefits as well too. So I'm not here to say which type of wire is better. Just know that you can get them from here. I generally would order wire from DigiKey though, because I find that they have a way better selection. So anyways, actually let's dig into it and see if we can find the wire here. It's been a little while since I ordered wire, so it might take me a minute here. Single conductor cables. Yeah, I think that's what we want right there. And let's go to in stock, and let's look at conductor. Let's look at like hookup wire. Boom, right there. There we go. And let's see, what else can we narrow it down with? So, wire gauge over here. I'm looking at the wrong thing. Okay, let's look at this 20 over here. Yeah, so forget that conductor strand thing I just went on about. Wire gauge, that's what we want right here. I don't know how I missed that before. Sorry, folks. But yeah, okay, so look at this. Oh, yeah, look at that. Yeah, now we're talking. Minimum, I don't know, like what's, oh, you need a minimum 5,000. What's this going to cost? Okay, so you can get like 500 feet of this for $100. Look at that, nice. And that's some nice green and white stuff that you could use for filaments or whatever. Yeah, look at that 300 volt wiring right there. And 28. Maybe you want to go with something a little bit stronger than that. Let's look at some 18. Let's see here. 18. Yeah, 18. Nice. That's the good stuff. And we can see here, you can go right across and look at all these specifications, like operating temperature for the wire too, voltage for the wire. That's a nice one. 600 volt. Be nice to get some 600 volt wire. Let's look at this one. Okay, so this one, $111, but you get 500 feet of it. And look at that. That's some beautiful 18 gauge hookup wire, rated up to 600 volts, so you know that you're fine and dandy to use that pretty much anywhere inside the amplifier, and be able to fit it inside the different lugs and tube sockets and things like that. Yeah, this would be really nice quality wire right there. And then just sort of pick the color that you like the most. Okay, let's keep going down the list here. What else can we pick? I guess if you were going to go with, real quick, if you were going to go with a solid state rectifier, you could go with some diodes. I'd probably get them from DigiKey real quick. I've just mentioned go with some 1N4007 diodes. That's what you would use for the rectifier in this if you're going with a diode-based one. Okay, knobs and switch. Oh yeah, they've got a bunch of knobs in here as well too. Just make sure that whenever you pick the knob that you want to put on your amplifier for, like, let's say knobs for pots, you want to make sure that the hole matches the shaft diameter of the pot. Let's just like click on these aluminum ones here, for example, and let's look at here. There you go, 6mm split shaft is what you need for these ones. So you couldn't use a solid shaft pot for that one. What about these ones here? Do they use a solid shaft? Solid shaft right there, 6.35mm. So that's what you need for a solid shaft right there. And you get them in all different colors and stuff like that too. And lots of different places to get your knobs from. Yeah, but this is a really great place to get some from here. And there's like a ton of different pages and styles and things right here. So there's a lot of selection. Well, folks, I think that pretty much covers everything that we needed to look at. Oh yeah, I just thought of maybe some more power stuff, like the power switch and say like the power jack, stuff like that. So let's go back at the power or the amplifier parts. Where are the power sockets, things like that? Jacks and plugs, maybe. Power jacks, there we go. And here we go. Let's go to page 2. And here's the one I typically put in most of my amp builds right here. You can just screw it right into the chassis. And it's a little tricky to get that square hole cut out. You know, maybe we'll discuss that in a future video. But here's the power jack that I would recommend for the build right there. And, oh yeah, switches. Yeah, we wanted to look at the switches as well. So let's go to selectors and switches. And we're going to go for large switches, which would be like for power. And here we go. There's all kinds of cool choices. And look at this beautiful toggle switch right here. It's $10, but this is perfect. It's not very big. It was really great feel. This is a really nice switch right here. You could go with this awesome Carling one as well too. It's kind of overkill. You don't need all the stuff that's on there. And I think that's a dual, yeah, it's a dual throw one, so maybe you don't even want to go with that. So forget about that. Let's go with this one right here. This real nice Fender style toggle switch. Can't go wrong with that. Anything else on the second page here? Oh yeah, look at that. Look, there's another one right here. Not sure what the difference is between that one and that one. Maybe like the on-off position is like opposite of that one. And look, this one has a longer toggle thingamajiggy on the end of it, which is nice. And here's another one right here. So, you know, pretty much any of these switches work just fine for the power switch. On that note, you'll see here that there's no standby switch installed on this. And if you wanted to install a standby switch, it's really simple and easy. You just get another one of those same simple switches like this one right here. And then what you're going to do is you're going to connect one side of the switch to one side of the B plus, and then the other side of the switch to the other side of the B plus, so that you can create a break in this B plus here. However, keep in mind that you don't necessarily need to do that when you have a tube rectified amplifier. It's really there to protect the filter capacitors. And you know what, let's not go down that rabbit hole right now, but maybe that's something for a future video. We can get into that. If you're interested, be sure to let me know in the comment section. Okay, so let's get back to parts. The only other thing I think that you would really need would be, I don't really know if there's anything else you really need. This is the death cap, if you will, but we're not going to bother installing one of those in the amplifier because, yeah, we don't want to have to worry about that. Well, there's only really one last thing to discuss, and that is how much is the whole thing going to cost? What does it all add up to? Now, we could go through each and every item and add them all up. That is one way to do it. And if you are going to build amplifiers for other people and, make a real go of this sort of thing, yeah, you probably want to do that to make sure your books are all straight and stuff. But there is a quicker and easier method that you can use to just get in the ballpark of what things are going to cost. And this is how I go about that. I break down the amplifier into sections because I find that components like the tubes, for example, are generally all around the same price, give or take a little bit. Like you could even use like a percentage tolerance, sort of like they do like for the circuit values for the pricing. Like for example, a preamp tube is generally right now in 2024 about $40 Canadian each, give or take maybe $10. And since this amplifier uses one preamp tube, then you know that you have to allocate approximately $40 to that. A power tube, which this amp has one of, is approximately $50 or maybe $60 Canadian. So if you look at those together, boom, that's $100 right there. The rectifier tube is probably another $60 Canadian. So therefore you could deduce that with $200, that's enough budget to get pretty much any tubes that you want to for the amplifier. And you could maybe bring it down to about $150, but yeah, you're probably going to be in that $200 Canadian bracket for the tubes. So there you go. There's $200 for your tubes right there. Now we want to look at one of the other most expensive parts of the amplifier, which is the transformers. Generally, the power transformer is going to be about $200, and the output transformer is going to be about $100, but could be up to $200. So let's say $400 for the for the transformers that you need for the amplifier. So we're at $200 for the tubes and $400 for transformers. So that's $600 Canadian for that stuff right there. Okay, now all the components and hardware like the resistors, caps, the chassis, the switches, the jacks, all that sort of stuff, I sort of lump into the same category of hardware. And generally speaking, all of that stuff adds up to about $100 Canadian. I try to keep it at about that budget. It depends on the size of the build, really, but give or take maybe $20 or $30, it's about $100 for all of the hardware. So that brings our total up from $200 plus $400 plus $100 to $700 now for the build. But that's pretty much all of the parts right there. Then, you want to factor in some stuff like wood, if you're going to do any wood for a cabinet. A speaker, what the cost of that is, so maybe a couple $100 or $300 for a speaker. For wood, I would just factor in maybe like $50 for that. So let's say $300 for the speaker and the wood. And so now that brings us up to about $1,000 for this build. Okay, so $1,000 is quite a lot of money, you know. There are ways you can reduce that by trying to get more affordable transformers. A great resource for that is those old stand-up radios. Often you can get those for a really great price, and they always have really great power transformers in them, really big ones that generally have 5-volt and 6-volt filaments in them too. And then you can eliminate $200 out of your cost if you can find one of those hanging around somewhere. So anyhow, there's lots of ways that you can keep the cost down, but be careful how you cut your costs, because every time you do that, you're going to run into compromises. But that brings us into that zone, you know, of like, well, like, where do you make your compromises and how do you save money and stuff? And I can't give you the answer to that. You've got to figure that out for yourself. And the way that you can do that is read the data sheets and learn the information, read the books, you know, watch videos, discuss it with your friends, you know, get out there into the community sort of things. And most importantly, believe in yourself, because the ideas that you have and the dreams that you have, they're yours. They don't belong to anybody else, and they can only be lived and realized by you. So it's your duty to follow through on your dreams and give it a go and see what happens of it, you know? It's very rewarding, and it's a very satisfying experience to play through an amplifier that you've built yourself and that you know is the only one in the whole world like it. It's really, really cool. It feels great. Okay, folks, well, I think that pretty much sums up everything that we possibly can in today's video. If I have forgotten anything, then let me know in the comment section, and I'll be sure to follow up and do my best to answer any questions that I can. I really appreciate you all watching, and if you enjoyed the video, don't forget to hit the like button, and you can subscribe to the Mears Lab channel for more videos like this as well too. Thanks again, and have a great day. I'll catch you later.